If it goes to the final state, it will accept, otherwise it won't be accepted. And there
Okay.
can be, if there is two different spellings, there can be two different final states, etc.
Yeah. So we have seen finite state automaton. What is finite state automaton? It is a kind of a directed graph. It is represented as a figure. Okay, if you take this graph, we have 6 nodes. Nodes are also called as states. There is a edges between the states or nodes. That is a line arrow mark, and above the edges we will be having the labels. Can you all able to hear me, students? Yes or
Yes,
no?
ma'am.
Okay. Edges are labeled with certain symbols. That symbols we call it as labels. Okay. Between node 0 and node 1, we have a label Z labeled with C. And we have a start state, that is, and an accepting state is also called as a final state. And we will be giving some regular expressions, and we will be checking whether it will be accepted by this automaton or not. Okay. The final state is given by a double circle. So all these we have seen. This is an finite state automata which we have constructed, which has only one start state and two ending states, and there is no intermediate states given here. We have intermediate, but here we have only start state and the intermediate state, which is used to recognize the regular nouns, singular and plural, irregular plural nouns, and irregular singular nouns. If my input is a irregular plural noun, directly it goes to an ending state. If it's an irregular singular noun, it goes to an ending state. If it is a regular noun, it may be if it is a singular, it ends with q1. If it is a plural, it will ends with q0 to q1, q1 to q2. And we have seen another finite state automaton for an English adjective words. Yes or no? We have seen for last class, we have seen, no, and it will accept some words. Next we will move to Morpho Tactics. What is Morpho Tactics? We have already learned, right? What is Morpho Tactics? What is Morpho Tactics? I think already I have told this word before itself. What is Morpho Tactics? Please look into your notebook and tell me what is Morpho Tactics.
Which class of morphemes fall under the class of morphemes?
Very good. We cannot tell that all class of morphemes will follow with everything. ED will not follow with the noun or something. Okay. So basically which class of morpheme will follow other class of morpheme? Already plurals with noun. Okay, plural always follows with noun, like that. We'll be having some rules. Which class of morphemes follows which class of morphemes? That we call it as morphotactics. Okay. So here we'll see lexicon, how to include a lexicon in a final state automaton. Okay, so this is normally a final state automaton, which is a diagrammatic representation to show whether your input is accepted by the given FSA or not. But that is not our regular goal. See, this is a final state automaton for English language to identify whether it's a regular noun with singular or plural, or irregular noun singular plural. That is not our aim. Our aim is what we are going to see. So see here, so now we will be adding a lexicon to it. So this is a normal finite state automaton. Now I am adding a lexicon, mini lexicon to it. So the same finite state automaton, I am changed like this. So previously what I had a regular noun, or if it's a regular singular noun, it will end with q1. If it's a regular plural noun, it will end with q0 to q1, q1 to q2. If it's an irregular plural noun, it will end from q0, it will go to q2. Irregular singular noun, it will go from q0 to q2. Yes or no? So same thing, we will add some lexicon to the FSA and we will see how it works. If I have a word called boy, dog, bag, all these are regular nouns. Okay, men is a man, and men is what? Boy, dog. What are the words? We can see it in this picture. Can you list out, students? Bag is a word. Please list out what are the words you have in this diagram, right? I have
Bag,
added a
boy,
lexicon.
dog,
This is
men, bag.
very good. So the previous one, we have a normal final state automaton. Now I have added some lexicon to it, to a final state automaton. So we have words like bag, boy, dog as a regular noun, man as an irregular noun. If I want to generate or recognize all singular and plural form, what to do? From Q0, now having all possible intermediate states. Yes or no? We have intermediate states or not? Previously I told you there is no intermediate state. Simply I have Q0, regular noun I have. So this regular noun I made it as a lexicon word by word. So now I have an intermediate state. So from Q0, now having all possible intermediate states that recognize, that take the regular noun to which one? Regular singular noun to which one? From Q0, now I have all possible intermediate states. So that will take your regular noun to which state? That will take the regular noun from Q0 to which state? Regular singular noun.
Q1.
Q1. Okay. So irregular nouns have different paths, right? What is the path we have given in the previous one? What is the path we have in the irregular noun? For irregular, either it may be singular or plural. What is the different path we have? Please tell me from this diagram.
Q0 to Q2.
Q0 to Q2. Okay, for regular noun, I have a path from Q0 to take a word to Q1, then add S to get a plural, right? For irregular nouns, different path. So here also, if you see by adding a lexicon, so there are many intermediate states I am adding to it. So these are all the singular regular nouns with singular. So if I have a regular noun, so this finite state automaton recognizes three singular words: bag, boy, and dog. Singular regular nouns, and regular plural nouns like bags also, dogs also, boy. If I give boy, it will recognize. If I give boys, it will recognize. If I give dog, it will recognize. It will give dogs, it will recognize. And it will also recognize the man and men. Okay, different irregular man and men. See, there is a separate path. Why there is a separate path? This is given because in the previous slide we have separate path for what? There is a separate path for the regular noun and separate path for the separate. Please be active first morning. Separate path for the, we have a separate path for the irregular nouns. Very good. So here also man and men, we have a separate path, different path for man and men. They go to Q2 directly. Given the figure, we can recognize the words. We can recognize boys easily. Whether we can recognize the word boys easily in this finite state automaton? Whether you can able to, yes, how to recognize? We can trace it from Q0, it will go to B, from B it will go to O, from O state it will go to Y, from Y it will go to Q1, from Q1 it will go to S, then it reaches Q2. Okay, so what is her automaton doing actually? Given a word in English, it will tell me whether it is a singular or a plural word in English. Singular word, it ends with Q1. If it is a plural word, it will go to the state, it reaches the state to Q2. Assume that you have taken care of all the words in the vocabulary. So like this, I have taken only few words to show you as an example. So you have to construct a finite state automata by thinking of all the words. Okay, so assume that you have taken care of all the words in the vocabulary while building an automata. So we have to take care of all different types of words. I am talking only regular noun, irregular noun, like that. All possible words you have to take it for building an automata. So if you take a finite state parsing, what is the minimum requirement we want is, we want a lexicon. What is a lexicon? It is a word, bag, boy, like that. And what is a stem? Boys, bags. What is an affixes or prefixes attached to it? So it is a list of stem words and affixes, suffixes together to give a basic information. Okay, so that we need to construct a finite state automata. And morpho tactics also you should know. Okay, you should know some rule, what type of morpheme will follow what type of morpheme. Like that, you should have some basic knowledge about the English. So the model of morpheme ordering, that explains which class of morpheme can follow other class of morpheme inside a word. That type of rule. Okay, plural morpheme follows the noun rather than preceding it. It follows the noun. It will not precede the noun word. Okay, like that you should have a proper morpho tactics. It's a morpho tactics is the telling what type of morphemes follows what type of morpheme. Then you should also know about, so if you want to construct this type of orthographic rules, you should have these basic knowledges. Okay, morphological parser. So last one is the orthographic rules. Orthographic rules are spelling rules. Sometimes boys to become plural, it becomes boys plus s I can add it. But if it is a flies or cities, so directly I cannot write CITY plus S, it becomes cities. Flies means FLY plus S, I cannot write FLYS. Okay, so you should have some orthographic rules. What type of ending word? If I have a character ends with this. So if I add a plural this. So this plural in this character ending, whether it will go with this type of plural, this type of suffixes to make a plural form or not. That type of knowledge. Rule form also, spelling rules also you should have it. So these spelling rules are used to model the changes that occur in the word. Usually when two morphemes combine, boy plus s, yes, it gives boys as a plural, proper thing. But fly plus s, it will not give a proper plural. So what type of orthographic rules you have to frame? So if my stem word ends with y and if my affixes ends with s as a plural, then y rule has to be changed to I rule. Like that you should have some rules accordingly. So these are all the minimum requirements needed for constructing the finite state automata. Okay, so that's some properties. Again, recognizing a problem in a linear time, you have to go in a linear time. There is an algorithm to transform, even if your automaton is very big, some extra this one is the states are also there is an algorithm to transform each automaton into a unique equivalent automaton with the least number of states. Even with the least number of states also we can able to process the same output. Okay, so one will draw with 10 notes saying everything, one will draw with 3-4 notes showing everything for the same input. Okay, so you have to try to draw with the minimum number of notes, and even if it is a DFA, we can able to transform to an NFA. Okay. But now this is not our goal. What is our goal? Simply giving a word, drawing a final state automata, checking the whether word is accepted by this final state automaton is not a correct thing. Okay, whether it is accepted by the FSA or not is not our goal. What is our goal? Can anyone tell me what is sufficient? Whether is it sufficient for morphological process? Is this enough? Drawing a finite state automaton for all the words present in your dictionary, and if the word passes to that, then it is accepted by the automaton or not accepted by the automaton. These are all the basic things to understand what is FSA, how to construct an FSA, how to add a lexicon to an FSA. Is it sufficient, or what is required for morphological process? That is one word I wanted. Is it enough for morphological process what we are studying, or any other thing is required? What is actually required? What is actually required from morphological process? We have already seen, no?
Spelling correction, ma'am.
Spelling correction. No, I have given one syntax, right? One rule form. What actually the final output of morphological process?
Stem and POS.
Very good. Stem plus POS tagging should be, that stem is the lemma root word for each and every word. Our main aim of the morphological process is from which word that word came from. That is a lemma or the root word or the stem word we have to find. And what is the one more thing, Vishnu? We have to find out what is the main aim of morphological process. We have to find the saw. If I give a saw, it comes from a root word see plus it's a verb or it's a noun. Like that we have to tell what is the root word and what is the POS tagging of that word according to the corresponding sentence. In that sense, each word will have multiple POS tagging. That POS tagging we will be studying in the next chapter. So which is the correct POS tagging for that word? That depends upon the sentence where that word is occurring, in which form the word is occurring, in which angle the word is occurring in the given context, in which context the word is occurring. Okay, based on that the word will have multiple POS tagging. Okay, don't think that if I take an English word, one word, that word will have only one POS tagging. No, it can have multiple POS tagging based on the context in which it is occurring in the domain or in your corpus. Okay, so what is our main aim of the morphological process? What is the main aim of the morphological process?
To find the stem and POS tagging.
Very good. We have to find the stem and the POS tagging. So given a word, we have to find the root word and we have to find the POS tagging for that word. Okay. So remember, so take a word boys. Remember different morphological analysis is there. Okay. Like we have to do lemmatization. What is lemmatization? Finding the lemma. Okay. We want to find the word boys. For the word boys, what is the lemma? What is the lemma? For the word boys, what is the lemma? Can you all able to hear me, students? For the word boys, what is the lemma?
Boy.
Boy.
Boy. Okay, boy. Okay. So if I tell that boys is a word in my defined regular language, it can be either a singular boy, the word with a singular, or plural. But I can tell you, but in an FSA I can tell you, if I give a word, it can tell whether it is a singular or a plural regular noun. But it cannot tell whether it is telling the lemma for the word boys. In the previous examples, what we have seen here, it will tell, if I give a word boys, it will tell it is a regular noun with plural. Whether it is telling the lemma, whether this final state automata is telling the lemma for that word. What is lemma actually? What is the term lemma here?
Root word.
Root word. So whether a lemma is shown here. Whether we can able to find the lemma from this given diagram, finite state automaton, it will tell whether the noun, whether it is a noun or a verb or a singular or plural or adjective. Okay, all these only it is showing. Whether it is showing the lemma, whether it is showing the lemma or not, whether we can able to find the lemma of the word here in this diagram.
Yes, ma'am.
No, from the
Q0 to
diagram,
Q1 is the lemma, no, ma'am.
Q0 to Q1
Q1,
is
boy.
okay. Okay, wait. You are telling Q0 to Q1 for something. Whether for men, what is a lemma?
That we can't find out.
Huh? What is a
We
lemma?
can't find out.
We can't find. What is the actual lemma for men?
Man.
Man.
Man. Whether it is showing here, we can able to find man as a root word for men. Since you know that English and you know that, so you are telling man is a root word for the men, and it is a plural. It is a plural irregular noun, so it is representing men. So that is the main thing we want. We want the lemma and the TOS tagging of the word. For that only we are going to the finite state automaton or the language recognizer. It will recognize the language or language generator. It will generate what is that language is about. It's a boy with singular plural. Only that much maximum it can give the information. So what we are doing is, I need some other model that gives that given a word, it should give the lemma or the root form of the word. Okay, so I need not a final state automata is not enough to identify the lemma for the given word. So what I have to do is, what I need is some other model that gives a word, that given a word, it should give the lemma or the root form of the word. Okay, so that form we call it as a transducer. Okay, that model we call it, we need a transducer to do the morphological analysis. Okay, so what is a transducer? Okay, finite state transducer, it translates the string from one language to string in another language. Like FSA, it is same as FSA, but every edge is, in FSA every edge is associated with how many strings? In finite state automaton, every edge is associated with how many strings? If you take one edge from B to O or Q0 to Q1, the edge is associated with how many strings? How many label? One character or more than one character?
One character.
One character, but here transducer will be having two characters. Like it is same as FSA. What is transducer? Transducer are similar to FSA, but help us to translate one string to another string, that is men to man. It helps us to convert the root word. Men is a word, convert to one string. How they do that? Model is very similar to FSA. Each edges of the FSA, instead of having a single phoneme as a label, I have input character symbol and output character symbol also in transducer. Understand, every edges of the final state automata, instead of having a single phoneme as the label, I have an input character symbol and output character symbol. So if translate one character symbol to another character symbol, that solves the problem of. So if I translate one character symbol to another character symbol, that solves the problem of going from the input string of boys to the output string of if my input is boys, what should be my output?
Boy.
So it translates one character symbol to another character symbol. That solves the problem of going from the input string of boys to the output string of boy. So what is the differences? In finite state automata, we have only input character, whereas in transducer, for each input we will be having an output character also. Okay, so if you see this example, okay, consider the example transducer having 4 words. Okay, the same thing with the finite state automata with the transducer. So the transducer, consider this example wherein we have a transducer with having 4 words. Okay, each edge is labeled with what? Each edge is labeled with what? Please be active, students. Each
Input
edge.
and output.
Very good. There we have only one label input. But each, if my input is like this, my output lemma word will be like that. Okay. See, if Yes or no, students? Can you
Yes,
able to
ma'am.
make out here? See, if I give a word called bags, what is my lemma? What is my lemma?
Bag.
Bag. It is not bags, but I want bag. So how I can take that from finite state automata? I have to make some modification, that is a transducer. Instead of only having an input character, I will be having the output character also. I am getting some sound. What is the problem? Anyone can't able to see, hear or something? Can you all able to hear me, students?
Yes, ma'am.
Yes, yes, yes. Okay. If you can't able to hear or something, please immediately tell me, okay? Because sometimes Wi-Fi connection will not be proper. So we have a finite state automaton in each which input character, only input character. Finally, FSA it recognize the word which is whether it is a word or not. Where it will recognize whether that finite state automata recognize the word or not. Okay. So here every edge is labeled with input and output character. So you take this example men. So take this word men. In input character, M is replaced with what? What is an edge for men? What is a path for men? Q0 to here, to this to here, this to here. So if I take M in the input men, MEN is my input word. So M in the input character, the output character is also what?
M.
M. So E in my input character, what is my output character?
A.
A. N in my input character, what is my output character?
N.
N. So if my input is men, what is my lemma output? Transducer will give an output lemma. So what is my lemma here for men?
Man.
Man. So if my input is boys, boys. Okay, what is my root word? First you tell me. What is my root word? How I do,
Boy.
what is my lemma? Boy. So how I will get it? Boys. Take this path B. For first word B, it is B only. For input O, what is my output character?
Only.
O only. For Y,
Y.
Y. Whether it will stop here? No, I have S also in my input character. Yes or no?
Yes.
Yes, ma'am.
Yes. So it from Q1 to Q2 it will go. So for S character, what is my replacement character, output character? To get a root word lemma?
Empty string.
Empty state, epsilon. So what is a lemma I'll be getting if I give my input word boys?
Boy.
Boy. I think only 80 students are joining, 30, 35 students are not joining. I cannot go back there, check, and I cannot come back again here. I can really make out who is overall listening, overall telling, and able to answer in Viva also. And who are all not there, I couldn't make out. And I have noted their names. Now if I call out, only time will be getting wasted. See, out of 103 students, only 85 students are there. 30 students are not there. Every time it is a problem. Wait, last 10 minutes I'll call out. I'll finish off this only 5 more minutes is there. I'll finish off, then I'll call out and I'll find out. Okay. So this is how the transducer works to find the, so normal finite state automata will not help us to find the lemma. So you'll be adding a transducer. The transducer is same as finite state automata having states and edges. Only thing is each input character is represented by its corresponding output character to find the root word. Like that we can solve the morphological process. So what problem we might face while doing this? Input cat convert to cat to noun with plural, it will give cats. Okay, but output, okay, so what we want actually, we want the root word and the POS tagging and the other information also, right? Yes or no? So how to find the root word? What we want, actually what we wanted, morphology, lemma, POS tagging, and the other information. It's a plural or singular, or it's a past tense, present tense. Okay, walked. It may be a past tense. Okay, walked, walk plus verb plus past tense, like that we will be giving all the information. So given the input cats, we want the output as this is the final form. We have seen, right? Previous one slide I have shown in the last class. If you want, I can go back. Just slide. I told no, this is the way we want that information. See, this is the form we wanted, right? This is our goal, right? Yes or no? We have seen the last to last class, right? When we are discussing, yes or no,
Yes,
students?
ma'am.
This is our output. If I give cats, it should give the root word and it should give a POS tagging plus it is a plural. If I give cat, it is cat plus noun plus singular. If I give cities, it should give city, not it should not give CITI. It should give CATY plus it is a now what is the POS tagging and what is the this grammatical form of that word. So this is our morphological parsed output. This is one we wanted. So that is one we are trying to figure out here. Okay. So given the input cats, we want cat plus noun plus plural. Okay, so telling us the cat is the plural noun. We have to tell that. Okay, so how we can do that? We can do with two-level morphology. What is the two-level morphological processes? The first level, surface level, will be the lowest is the surface level. Surface level will be inputting the input string cats, and the higher level is a lexical level. So that lexical level will give what is the root word lemma. You have to find out from the transducer, and whether it is a POS tagging. Using POS tagging, that POS tagging we'll be learning in the next chapter. We'll be finding out whether it is a noun or a verb, and it is a plural. So it is whether it's a singular. If it is affixed with S, you have to write a rule like it is a plural. If it is with ED, it is a past tense, like that. You have to give the grammatical sense of that particular word. Okay, whether the two level is enough for all the process, all the words, or for some words it may give difficult. Can you think and tell me? Given an input lexical level, I am getting cat, because if I'm using transducer I can get the root word as cat, and by using POS tagging I can find out cat as noun or verb. Okay, that you will be anyhow studying this, and you will be finding out based on the affixes or suffixes. You can tell out whether it is say a plural or singular, or it's a past tense or present tense or continuous, walking, ing, walked, walks, like that. Based on that suffixes ending, you can tell the grammatical sense of each word. Whether this two level is enough to convert the stem words and the POS tagging, or it is difficult for some words. If it is difficult, can you give me an example for which words it will not work properly? Can you find out and tell me, think and tell me for which words it will not work properly? Can't still make out? Is this two-level morphological process is enough? If I give a word called fox, now you tell me. If I give a word called cat, you can tell it is cats. I can tell, you can tell cat plus noun plus plural. Okay, cat will give cats. Yes or no? Yes.
Yes.
Yes. If I take a word called fox, what is a plural? What is a plural? I am asking the normal English only, right, students? Fox, what is a plural form? What is the plural form of fox? If I give a word cat, what is the plural form? Cats. So you can write as cat plus noun plus plural. If I give a fox, what is a plural? How it is represented?
Foxes.
Foxes. So what is the spelling?
Foxes.
Yes. But cats, CATES or CATS only?
CATS.
Okay, cat, fox, everything is a regular noun. When it is converted to a singular to plural, for cat, it becomes cats directly, S. But for foxes, if I cannot write FOXs, X's, right? It will give foxes changing in the, so what happens here for foxes? Can you tell me changes in the boundary by adding? So there is some changes in the boundary between the root word and the making a plural, right? Two morphemes. What are the morphemes I have for cat? Cat plus S. It becomes cats. Yes or no? Yes or no?
Yes.
For foxes, what are the two morphemes I have? Fox plus S. So if I add fox plus S, whether it will be a correct word for plural to convert a fox from singular to plural foxes?
No.
No.
No. So there is a change in the, where there is a change occurring?
Boundary.
Boundary of the
Stem
stem
and
word. Very good. Affixes. Okay, right? So there is a change in the boundary. So what is the change I am doing to convert fox plus FOXES?
adding a new letter.
Very good. Adding a new letter to it. Any letter it can be. Okay, now for foxes I am adding E. For flies, cities, Y rule I am applying. Here X rule. Yes or no? If my stem ends with X and my boundary is S, then what has to be added here? What is the rule, general
E.
rule? E. Box. Converting to plural. What will be the plural form of box?
Boxes. Yes.
So again, X, if it ends with X and my suffix, then my another boundary stem, the other morpheme is S. So in between X, if my stem word ends with X, so you have to write a rule like this. If city, fly, all these plurals means Y. My stem word ends with what?
Y.
Y. So there, what rule I have to apply?
Y to I.
Y to I rule. Here X to adding E. Okay, adding E to it. So like that you have to find and you have to make a rules for every word to make it as plural. Okay, so for foxes, adding E between fox and S. Whether that will be possible in two-level morphological process. Lower level is a surface level, higher level is a lexical level. Your output. Directly I can go to output for fox. Whether I can go to fox? No. So what I have to do now, many ways to handle this. One way is taking what we can do is we can have a two-level lexical form. Instead of this, we can have a two-level lexical form that is between the lexical level, surface level and the intermediate level. Okay. So we can have one intermediate level. So for foxes, it is noun, fox plus noun plus plural is my output. Yes or no? Yes or no? My output is foxes, Foxes. Okay, so foxes, what I can write? Fox, if my ends with X and if my other stem is S, there should be some intermediate placeholder that comes between X and S. Okay, for any word you can write it. That placeholder can be replaced with E or placeholder can be replaced with the null. For which case it can be replaced with null?
Cats.
For cat to cats, it will be replaced with null. For fox to foxes, it should be replaced with, it should be
E.
E. So between lexical level and surface level, in order to overcome that problem, we have an intermediate form which represents the root word and some placeholder. Okay, that placeholder can be null or E or Y or I depending on what type of phonemes available in the stem and the surface level. Depending on what type of phoneme you have, fox, X and the surface level in the stem and in the surface level, that placeholder will vary, so that instead of going from lexical level to surface level directly, because it will not work for all types of input, we have some intermediate level first, and then from that intermediate level, based on that what type of phoneme you have in the root word and the suffixes, we will be making a lexical level. Okay, so this is called as a two-level morphological process. So instead of directly going from fox to noun plus plural, we will be having fox plus some placeholder plus s. Okay, then this is the end of the sentence. Hash is to represent the end of the word. Okay, so fox is a stem and suffix is s and the placeholder may be e. Okay, that placeholder is now it is given as a cap that will be replaced. It can be filled with null or any character based on the phonemes. So my intermediate, from that intermediate level, I will be having a surface level. I will be getting foxes as an output. Okay, so from the intermediate level to the surface level, depending on what are the ending characters of the stem and the starting character of the suffix, depending on that, these words will be given these what should be the replacement character for the placeholder. Okay, so this is how we have to convert from the one word to another. So finally we will be getting a lexeme and the POS tagging of the word and some grammatical information of that. Okay. This is the diagram they have given. Fox, singular if it is fox, noun, and if it is a plural ends with s, singular for the same, goose and geese. So this is why this is a separate path. It's a regular noun or an irregular noun? Goose
Irregular.
and irregular noun. Okay, you can look into all these examples. Okay, the same thing they have drawn a finite state automaton. So this is how they have given for foxes. You see spelling change rule. Foxes. So fox plus I cannot directly add s. So I will be having some placeholder and s and with the end of the word. Okay, so that placeholder can be replaced with either e or any other thing or empty also for some words. Okay, it's surface level. Now, so all these they have given some rules. Okay, so they have given only one rule how it can be represented. So like this you can write any number of rules. So can you tell me what if this rule is like this? A implies b, a gives b if it is C hyphen D. So if the rule is written like this, what you have to do is A should be written as B if it occurs between C and D. So this is the rule notation they have formed. Like that you can write a rule in your own way for converting. If my stem ends with X and it is S, so this should be replaced with S or it should be replaced with E for city Y rule. Like that there are different words with different combinations. So they have made a rule and they have given one rule notation. Okay, if I want to rewrite A as B, okay, and that A should occur between C and D. So how they have framed a rule? So can if my input is for example CAD, according to this rule how it will be converted if I am writing a rule like this? If my input is
CBD.
CBD, if my input is CBD, what will be my output?
CBD.
CBD only. So if I have a word A, that will be replaced by B only if and only if it occurs between C and D. So this is how they have framed a rule. Like that you can frame any number of rules like this. I am telling A can be replaced by B only when the A is occurring between C and D. Okay, that is A comes between C and D. Then the character then change A to B in the intermediate. In the intermediate form, if the A comes between C and D in my intermediate form or word, then in the surface level, then it can be changed to B. Okay, use these rules to convert from the intermediate level to the surface level. So you can write a rule like this to convert from an intermediate level to reach the surface level. This is one sample rule they have given it. Okay, like that you can have any number of rules you can write it. Okay, have deletion rule, E insertion rule, Y replacement rule, Y tries, watches. What is here? Make. See this example, beg to begging. EG is replaced with what? Consonant doubling rule is there. E deletion. So here make to making what I am doing? Make to making what I am doing?
Removing the E and adding
Add
ing.
the ing. E deletion rule and adding ing. Make to making watch to watches. Same insertion we have seen, no, fox to foxes. E insertion rule. Here E deletion rule. Okay, here what I am doing? What I am doing? See, where are all there? These are all the characters I can end here before S. So E ending rule. Y replacement rule. Y is replaced with what? Changes to? Y will be changed to make it as plural. Orthographic spelling rules. What is here? Y replacement rule. What they have done?
IES.
Yes, this is one some sample orthographic rules there. So you have to in your corpus you have to find how it will be converted to other form. You can write like this and you can make some orthographic common form like this and you can convert that one form to the another form. See, that will not work for all the words directly. See, back to backs it will convert. Okay, but fox to foxes, if I have foxes also, you cannot take foxe. See, bags, you can take the root word as bag by removing s. So wherever s is there, plural, you cannot take the root word by taking removing s as a root word. That will not work. Whether that will work? That will work for all possible combinations. If I want to find the lemma, if my root word is a plural form, if I remove s, whether I can get the lemma of that word?
No, ma'am.
Why it will not work? In which cases it will not work?
Whenever there is ES, IES.
Okay. Hmm. See here they have given this form orthographic rules. So wherever insert E on the surface level, if we are ending with X, S or Z and we have a plural, next morpheme is S and it is the end of the word. Like this also you can make it. Okay. That word if it ends with X, S or Z, you have to insert E. See, insert an E on the surface level. When the lexical tape has a morpheme, lexical word has a morpheme, ends with X or S or Z, like that, you can frame it. And the next morpheme should be what? And this and the next morpheme is what? Next morpheme should be what? What is morpheme?
S.
What is morpheme? In foxes, what are the morphemes we have? In foxes, what are the morphemes we have?
Fox and
Fox.
S.
S. So S is also one morpheme. Don't tell FOXE as one FOX plus S. Okay. So X is other morpheme, like that. You can frame a rule and you can finalize it. So this is the end of the morphological process. So morphological process. Next, if you learn POS tagging, then you will be understanding better to understand analyze. What is morphology? Study of internal structure of the word. Internally, how the word is framed. How many morphemes are combined. What is a root word? In that, if you take boys, boy plus S, two morphemes are combined. Where boys, we call it as a root word or we call it as what morpheme? Free morpheme, right? What is the, in boys, boy plus S are the two morphemes. In boys, how many morphemes we have it?
2 boy plus S.
Boy plus S. So we'll be having two morphemes. Study of internally, the word is framed by adding two morphemes, boy plus S. Where boy is what type of morpheme?
Free.
Free morpheme. And S is what type of morpheme?
Bound morpheme.
Bound morpheme. So free morpheme is usually the free morpheme will be the mostly the free morpheme will be the stem word or root word, but that will not give exact stem word. Okay, sometimes that also has to be changed to the correct lemma based on the lemma. Okay, you have to find the lemma and you have to find the root word. Okay, saw it comes from the root word see. Okay, so like that it will come from the root word. So here you will be finding out the root word and the p word. If a word has multiple p words tagging, we will be seeing in the next chapter what is p words tagging. How if a word has multiple p words tagging, which is the correct p words. I will give a sentence. Sita is singing. Okay, so singing may be a noun or a verb or an adjective they will give. So which is a correct form of the p words tagging for the word singing. In this context, Sita is singing in the garden. Okay, so I'll give one sentence for each word. I'll give multiple keywords tagging, and using the probabilistic model, you will be finding out which is the correct probability, correct keywords tagging for each and every word present in the sentence. Okay, that you will be finding out next. So here you will be finding out which is the we will be finding out what is the root word, and there you will be finding the keywords tagging, so that we can find out what is for each word, what is the from which root word it is coming, and what is the POS tagging for it. Okay.
Ma'am, I
Ah,
had a doubt in the quiz question, ma'am.
which one?
NLP helps computers communicate with humans in natural language, no, ma'am?
Yeah, but in that computer uses which language? I am interpreting in that way. I told you, no, somebody has asked you that day also.
But in the slides also it is
Slides
given.
it is given like that, but I am telling computer, see, NLP helps the